Well, hello Internet, and welcome to my D video tutorial. In this one tutorial, you're basically going to learn what you would learn in a standard 300-page book on D, and basically D, if optimized, runs as fast as C++ while being a very readable language that can do just about anything, and I have a lot to do, so let's get into it. Okay, so I have a basic text editor on the left, and on the right side I have either a terminal or command line. Everything is going to work exactly the same on Windows as well as Mac. And underneath the video, I have a table of contents that you can click through to find exactly what you want to find in this giant tutorial, as well as in the description, I have a link to all the code that is heavily commented. Now on this, what you see right here is basically all of the different modules that I'm going to be using over the course of this tutorial. And a comment is just two dashes like that, and a multi-line comment is basically this. So just get that out of the way, and there you go. Now you have a multi-line comment. Now, whenever you first start executing your program will execute inside of a main function, and the void there just means that this function does not return anything. And over the course of this tutorial, I'll explain these different modules that are in there. But the first thing we're going to do is cover user input and do a little simple hello world thing. So let's say I want to put some information out on the terminal over here. I could come in and say something like, what's your name? And you're going to end all your statements with a semicolon. And I'm going to show you a couple different ways to read data. One way is with readf. And here what I'm saying is I expect a string that is going to be followed with a new line. And I'm going to want to store this inside of a variable called name. So let's go and create name. And it's just going to be a string, which is a string of characters, of course. And then after the user goes and enters that information, I'm going to output onto the screen a message that's going to be customized just for them. So I'm going to say hello and name. And the difference between write is there's no new line at the end of write, and write line, obviously there is. Now to compile this, you're going to come in, and you're going to type in DMD and whatever the name of your file is. And then you're going to put a period, a forward slash, and whatever the name of your file is once again. And I can come in here and I can say, what's your name, Derek? And it says, hello, Derek. Okay, so there is our hello world example. And now I want to talk about variables. Now, basically, variable names are going to start with a letter, and then they can contain letters, numbers, and underscores. And I'm going to create an integer, which is just going to be a value that does not have decimal places. And I'm just making up this wacky-looking variable name just to show that I can. Other types that are going to be available to you are things like Boolean values. You could also come in and just type in auto, and this is a Boolean, and the compiler's smart enough to figure out that's what it is. And of course I can come in here and output this information, so bool, and otherwise you would type in bool for Boolean, but either way. And then we can go bool1 like this, and you can see it comes back as true. And of course the values for a Boolean are going to be either the value of true or false. And to actually define a Boolean, you type in bool like this, and then I could say something like happy is equal to true. And you're also going to see I can go and get minimum and maximum values. So I can go bool minimum as well as the bool maximum values. And they're going to come back as true and false, just like I said previously. Also, if you would want to use formatted output, you could come in here and go write, and then just put an F inside of there, and then for a new line. And if you want to directly place a Boolean inside of here, value-wise, you just put a % followed by an S, and then you can put in whatever the variable is for your said Boolean. And there you can see that outputted as well. Okay, so Booleans are pretty simple, so let's go and cover some more stuff. You're also going to have characters, and characters are just going to be single characters that are going to be surrounded with single quotes, very important, as well as you're going to be able to use new lines and tabs and a whole bunch of other backslashed different commands, as well as double quotes and single quotes, and then finally backslashes. So you can store all those inside of characters if you would like. And we can come in here and I'll show you the minimum and maximum for all of our different characters. And you can do this for any of our data types, of course. And you can see that the minimum and the maximum actually come back as characters themselves. Likewise, if you wanted to use formatted output with a character, you could define a character, remember, single quotes, and then we're going to put that F inside of there, and we can come in character, and then throw A inside of there, and then you're going to change this S into a C. And there you can see we got our answer. Okay, so booleans are done, as well as our character data types. There's a whole bunch of different integer types that are available for us. So we're going to have bytes as well as shorts and ints and long. And there you can see all the minimum and maximum for all those different data types. And if you want to use formatted output for these guys, F once again. And let's go and define a long here because I want to show you something else. You can also come in and go long and then long num like this. And you can go and divide up all of the different numbers that you're working with here with underscores just to make things a little bit more readable. And then for every single one of these integer types, you're going to be able to go and use, this is going to be long num. You're going to put a percent sign and then D. And you could also do right shifting by coming in here and doing something like putting 15 inside of there. And that's just going to shift it to the right based off of the total size of whatever the data is that you're going to be outputting on our screen. And there you can see how it's shifted over, okay? Big block right there. Like I said, D is going to be used for every single one of these different types. Floats are going to represent numbers that have decimal places here, and what I want to do is demonstrate exactly how accurate the different floating point types are, which there are 3 of them built directly into D. So let's come in here and we'll say float, and then I'm going to put a percent sign and a 1, and then I'm going to say that I want 16 decimal places to show, and I'm going to put an F after that. And then I'm going to add these 2 numbers together so that you can see directly how they are, or how accurate this addition is going to be. And there you go. And you can see that this is accurate up to 6 decimal places, and then everything goes haywire. But there's other more accurate types. You can also use doubles. So let's just change this to double max, and then change this to double. And I'll leave these exactly the same size, and then change this to double as well. Of course, change these from floats to doubles. And we'll just leave everything else the same, and we can come over here and run that. And you're going to see that you get even more accuracy. Instead of 6, you're going to get 15 layers of accuracy, precision-wise. Then if you want even more accuracy, you can use a real. And you can see right here, all I did was added additional numbers in there because a real actually is going to be accurate up to 19 digits. And there you can see that it is. All right, so there's a rundown of those different data types. And you can also do a couple more data types here that I missed. If you would like to also get the default value for any of the different data types, you can just use this command, which is just going to be whatever the data type is you're working with, and then init. And we can see here that the default value every single integer gets is 0. But that's still not all. There's additional data types that you may only use occasionally, and those are going to be ubyte as well as ushort, uint, ulong. There's going to be imaginary values, ifloat, idouble, ireal, complex values, and so forth and so on for different types of strings. All right, so there's a rundown of all the different data types available to you inside of D. Now I want to talk about casting. Now, we very often are going to want to be able to convert from one data type into another. Let's create here an integer, give it a value of 15, and then let's create a short, which is a smaller amount of memory for you to store your information in. And to cast, you just type in cast to whatever you want to cast it into, and then followed with the data you want to cast. However, it's very important to understand that very often when you're doing casts that this can cause some issues if the container is too small, and I'll demonstrate that as well. So we'll go C short 2 is equal to, and we'll cast to short, and then C int, and let's throw, instead of C int, let's throw a big giant number in there. Let's throw in 32,768, and then we'll do short cast. So basically just make sure that whenever you're doing casting that you are casting into a data type that can actually hold that information. And there you can see I got negative 32,768, which is not what I was expecting, and that's just because the short was too small to hold the data. You're also going to be able to convert ints into strings, and like I said before, you can use auto and it'll automatically figure out what data type to give you. And how you do that is just type in 2 with an exclamation mark and then follow that up with string, and I'll throw 10 inside of there just to do something. Then I can come in and go type and get the data type of the integer by going type of, and this works for any data type, of course. And then I can go string of to convert that into a string. Let's do a couple more here. You're also going to be able to convert strings back into ints. So I can go auto iString is equal to 2 exclamation point and then int to convert a string into an integer. And then I can throw, as long as, you know, that's possible, I can convert 10 into an integer, obviously. And then we can come in here and then output the data type once again, except this time I'm going to change this into iString and leave everything the same. And there, if I run it, you can see that indeed the cast did work. All right, so there's a lot of information on casting from one type into another. And now I want to talk about math operations. Now, of course, you're going to be able to add, subtract, multiply, divide. This is modulus, which gets you the remainder of a division, as you can see right there. And you can either put the parentheses around there or not. And basically, math done on integers is going to default to an integer output, and doubles are going to return doubles. So let's say I come in here and I do something like 5 divided by 4 is going to be equal to, and then what I'll do is I will perform this operation on decimal places. So I'll go 5.0 and then 4.0. And you see if I run that it comes back using the fraction instead of what I might have been, what we saw up here whenever we did this division using integers. There's a whole bunch of different shortcuts that are going to be available. So you could do something like, let's say you had a variable and you wanted to add it to itself. You could just type in plus equal to and 1. That would be equivalent to saying variable is equal to variable plus 1, for example. You can also increment. And I want to show you something that's a little bit confuses some people. So this is increment me, which is just an integer. Now I'm going to go and show you increment me and how it changes. So let's say I go increment me and then I put plus plus after it, which just means that I want to increase its value by 1. And then I want to come in here and do the same thing, but I want to put the plus plus over here. And I want you to guess what the output's going to be in both of these circumstances. And you'll probably figure it out if you've programmed before, otherwise you might be confused. Here it comes back as 0, there it comes back as 2. Why? Well, whenever I called it the first time, whenever you put the plus after like this, that means that you want to shoot this output onto the screen, and then after it's on the screen, then increment it. Here what we're saying is we want to increment it first and then output it on the screen. And like I said, you can also go in here like this is equal to 10, and that's going to increase the value by 10. And if you're following this in order, basically this guy right here is going to be used for the casting, and then this is going to be used for math, and then I'm also going to cover random, okay? So basically everything that I cover is going to be up here in order, so you'll be able to easily figure out what modules are needed for each part. As per math functions, these are some of the most useful math functions that are built directly inside of here, and I'm sure you can guess what each of them does, and here is our output for all of them. Absolute value ceiling, which rounds up, floor rounding, all depends off if this was 0.5 or not, and all of the other different functions we have here. And then I'll roll this up here so you can see the different trig functions, and this is all in radians, of course. And we're going to do much more with math as we continue on. I didn't want to waste your time having you sit there watching me type all that in when you can just see it all at once. Another thing we have are date functions. We can do all kinds of things with date. So if we want to get the current time, I'm just calling this now time. You don't have to call it now time, definitely. And we can come in and go current time, and I'll say UTC to get this in our common way of working with dates. And now what I can do is I can come in and get the year, and I'm also going to be able to get the month, the day, and the hour, as well as the minute and the second. And I'm going to do some stuff with milliseconds here later on, so I'm not going to cover that quite yet. And this is current time with an uppercase T. And if we run that, you can see that it gave you all of the very, very specific information on the very specific moment in time in which I typed this command in. So there's some different ways to work with dates, and a little bit later on I'll cover a little bit more. And now I want to talk about how we can generate random numbers. Basically, let's say we wanted to generate a random number from 5 to 20. What we're going to need to do first is generate a random seed value. So I'm just going to call this seed is equal to, and I'm going to use now time, which I very conveniently just opened up here. And I'm going to get the current second, which is going to add some more randomness to this because that's going to change every second, obviously. Then what I can do is go rand and call random and pass in our seed, which is going to help it generate a random value. And then we can come in and generate these random values. And how I do that is, let's say I want a value from 5 to 20. I just type in uniform and the minimum value and the maximum value followed by rand. And that's exactly what it'll do for me. And you see if I run it, that it's going to give me a different value every single time. All right, so there's a whole bunch of different things we can do with math functions inside of D. Now I want to talk about arrays. Now arrays are going to allow us to store multiple values inside of boxes inside of memory using just one name, just like every other programming language. And let's say I wanted a fixed size array which is going to contain 10 different values. That's how I would define that. I could then also come in and just have it figure out the size of the array that I want set aside by just coming in and instead putting the values directly inside of there. That also works. I would be able to set values or change values just by referring to the array's name and the index that I want to change. Let's say I want that to be 0. And the index is just like an address for all of the different values that are stored inside of the array. And I could come in here and also output said information just by referring to that index as well. So if we come in here and do this, you're going to see that we were able to get that value back just by referring to the index. You're also going to be able to create a resizable array. So let's go like this, A3. And then in this situation, if you want to add values to it, you go A3 and then a tilde is equal to 1, and it's just going to append all these different values to the end of whatever is currently in the array. You're going to be able to remove different values at specific indexes just by referring to it again, and then restoring this back inside of our array. So we can go A3 is equal to A3 and remove. And here I'll say I want to remove index 1. I can then output this on the screen just like anything else. And there you can see it has been removed. You're going to be able to combine arrays. Let's say I want to go and combine two of these arrays, meaning A2. I just put a tilde inside of there and then store them inside of the A3 array again. I can do so. Now let's do some cool things. Let's say that we wanted to just get the odd values out of our array and then store them back inside of the array again. I can go A3 and then A3 and remove. I'm going to put an exclamation mark here, and then I'm going to do the condition for what I'm going to work with. So if we do a modulus on a value and divided by 2, and it gives you a value of 0, well, all that means that it is an even value. And if I go and throw that inside of there, you can see that I come back with just the odd values that are in there. And what this is doing is it's cycling through the array, getting each of the individual values, temporarily storing them inside of X, and then it's saying is the modulus of 2 versus that data equal to 0? If it is, remove it from the array and then store it back inside of here. So that's a neat little trick for going and manipulating arrays. We're also going to be able to sort our arrays. So let's go like this and sort and then throw our array inside of it. We're also going to be able to reverse the data inside of the array. And there you can see I was able to do that. Let's go and do something else. Let's say we want to replace all matches. So we could come in and do something by passing in our array and then follow that up with replace and say that we want to replace all 3's in the array with 2. And you can do this with all data types, not just integers, of course. You're also going to be able to get a range of values. So let's go and once again combine the A2 array with the A3 array just so we can get a bigger bunch of values here. And if I want to get a range, I can go A3 and then I just type in the indexes that I want to pull out of here. And there you can see I did. It's also easy to duplicate an array. Let's go throw auto inside of here, A4, and then go throw this in there and duplicate. There, I just duplicated it. Of course, I want to save it into the A4 array that's brand new. And you can also perform operations on every value very easily. So just like this, and then store it back inside of that array again. And that will multiply every value times 2. And then we can go and throw that inside of there, and compile it and run it, and you can see it works. All right, and for the final demonstration, I just want to show you a multi-dimensional array. And this is how we would go and create a multi-dimensional string array. And if you're wondering what these are, basically the way this is set up is this first box here is going to represent how many down, if you think like a spreadsheet or something like that. The next one's going to be how many across, and then this is going to be how many groups. So you can think of this as columns and rows, and then the final one is going to be like pages. So they're like stacked on top of each other. And here I went and basically laid them out exactly based off of how the multidimensional arrays are structured. You can see all that. And you can see the final output, which is 320, which is this lower right-hand corner part of our multidimensional array. And if at any time you're tired of typing stuff in, you can just get the code that's in the description. All right, so there's a whole bunch of things on arrays. Now I want to talk about strings. Now, strings are arrays of characters, but the one thing that's important is that the character values can't be changed. And you define one just by typing in string like I did previously. And let's say we want to do something like Doug. You can't, however, do something like this. This would throw an error. So don't do this or even, that. That's not going to work, okay? You're going to be able to come in here and get the values that are inside of there, just like you did with arrays. So you could do something like this, and that would work. You also will be able to come in here and change the entire string just like this. As a whole, you're going to be able to come in and get the string size just by going S1 and then getting length. And that would help you go and cycle through a string if you'd like to do that as well. You're going to be able to combine strings. You could do something like S2 is equal to S1 and again tilde, and then you could type in something like thumb. You're going to be able to find indexes. So let's throw T inside of there. And then you're going to type in index of and the string that you're going to be working with and the individual character that you are specifically looking for. You're also going to be able to get the last index of. So let's just call this last T. And then just change this into last with an uppercase IN, and everything else stays exactly the same. And you could also come in here and let's say you wanted to do thumb and leave this be index of and this be S2 and then type in thumb like that. And it's not going to matter in this circumstance. Let's put this in double quotes, however. But if you wanted this to be case sensitive, you could just type in case and sensitive like that. And you can also have this go on to the next line, and that's not going to cause an error. And if we run it, you can see all that output that comes. We could also come in here and find and replace different items. So let's go like this. We can say replace and the string that we're working with. And say we wanted to replace all instances of Tom with the name Ed. That works. You're going to be able to convert strings into arrays. Let's say we go string and S3 is equal to 1 and 2 and 3. We could then go auto and number array is equal to, and then we're going to use the 2 that we used previously. And I'm going to go int and say that I want this to be an integer array. And then I just say split and the array that I want to split. And then we can go and output that as well just by going number array and run it. You can see that works. So very useful. You can check for equality. Let's go and create another string here. Call this S4 equal to 1, 2, and 3. We could then come in and check for that equality just by using a simple double equal sign and S4. And you're going to be able to convert from upper to lowercase just by going to upper and then throw one of our strings inside of it. And then we can also do the same for to lowercase just by changing that to lower. And then finally, you can do a lot of the things that we did with arrays, since it is an array, aside from, like I said, changing specific indexes. You can also check if a string would be a numeric value or not, right like that. And if I got a semicolon, right here on this guy. And if I run it, you can see all of that output. All right, so quick rundown of working with strings with a disregard to the different things you can also do with arrays with strings because they're both arrays. And now I want to talk about associative arrays. Now, associative arrays are key-valued pairs, and let's just go and let's create one. So I'm going to go double and string, with the double being the actual value as well, and the string being the specific index. Then we could do something like favorite numbers is equal to, and you can go and you can skip to the next line if you'd like to list all these out. So we can go favorite numbers. So we could then go do something like absolute 0, and that would be the index, and then this would be our value, and a comma, and then you could go and put in here as many of these guys as you would like. You could then also come in and add in additional key valued pairs just by specifically listing an index, which just as long as it follows the rule that it's a string, it can be anything. And let's go and add in another one here, like that. So now we have 4 of those different key value pairs inside of this. We could go and output them all at the same time. Or you could come in here and instead just use an index to get a value. And there you can see all of them as well as the specific one we were looking for. You can figure out the total number of values that you have inside of the associative array just by listing its name out and then following that up with length. You could get just the keys or just the values just by listing the associative array's name inside of there and then followed with whether you want the keys or whether you want the values. Again, there you go. And also, of course, we're going to be able to check if a key exists, and all you do is go if, and we'll get more into the if statements here very, very soon. It just checks a condition like in all other programming languages. So we'll say if favorite numbers has an index of absolute 0, then we want to remove it. And this is how we would remove keys and values from an associative array. And then we can go and output that again just to verify that it indeed was removed. And it was. All right, so quick rundown of associative arrays. Now I want to show you some more ways you can receive user input. All right, so previously we had you go and actually type in that you wanted a string and then a new line. Let's say you don't want to do that. Well, another thing you could do is store the input inside of an array. So we'll go array name, which is a character array, of course. And then we can come in just like we did before, and we can say, what's your name? We could then use read line, which is going to read until a new line comes through or the person hits the return key. And then say we want to store that inside of array name. And then we can come in here and output that information. So let's say we want to say hello. And then we want to strip off any white space or any new lines that are currently inside of the array whenever we output this information. And we run it and we can say Paul and it says hello Paul. All right, so there's another way to accept it. Another thing you can do is receive multiple values all at one time. So let's say I wanted to get the first and last name. Well, I can go and get rid of this. And then I could say something like enter first and last name. I could then come in and go string f name for first name is equal to, and I can use strip again to get rid of any types of new line. I can go read line like that. Now what I'm going to do is come in and go string first name and last name, and then I'm going to define the input that I expect and then separate it, and I'm going to use formatted read, go fname, and then specifically define exactly what I'm looking for, which is going to be one string, a space, and then another string. And that will transpose that directly inside of there. And then I just go and output that information. So I'll say hello and get the first name, throw a space inside of there, and go and get the last name. And first and last name. And there you can see it worked. Whoops, and I forgot to put this in here. And then if I run it, you can come in here and if I can spell my name like that, and you can see that it worked. All right, so some more ways to receive user input, and we'll get into more whenever we talk about files and such, but now I want to talk about conditionals. Now with conditionals, we're going to be able to perform different operations depending upon different conditions, and you have your relational operators, greater than, less than, greater than, equal to, less than or equal to, or not equal to, and your logical operators and, or, and not. And now I'm going to show you how they work. Basically, let's create an integer called age and perform different operations depending upon that age. So let's first cover the if statement, and I'm going to say that if the age is greater than or equal to 5, and both conditions need to be true for this operation to go forward, and the age is less than or equal to 6. Well, I'm going to use curly brackets here, and then I'm going to say go to kindergarten. And then if we want to check other conditions, we can just say else if, and then we're going to perform a very, very similar operation here. So I might as well just copy this and throw this inside of here. And here I'm going to say if the age is greater than or equal to 7, or it is less than or equal to 13, then I'm going to say go to middle school. So middle school. And then we can continue on and on and on like this over and over again. So just else, and make sure you throw in your if statement, unless that's the final statement, which we're going to get to in a second. We could say 14 and 18. And then we would change this to high school. And then as your final condition, we can just say else. If everything else is not true, well, in that situation, we will throw in a default, which is just going to be stay home. So it works just like if else and so forth statements in other programming languages. And there you can see your output. All right, so we also have the ternary operator, which is going to, based off of a condition, provide a value of one or another. So we can do something like bool, and this doesn't have to be a Boolean, it can be any data type. We can say can vote is going to be equal to, and if the age is greater than or equal to 18, then we put a question mark. If this comes back as true, we are going to provide a value of true. Get rid of that colon inside of there because it's going to go right here. Otherwise, we are going to store a value of false inside of that Boolean. Switch is going to work great when you have a limited number of options. So let's say we have language defined inside of here. We could say France, and then what we could do is say switch, and we are going to be checking for the value of lang. And we're going to do this inside of curly brackets, and we're going to say if the country is Chile. And then let's say we wanted to check another condition. Well, we could come in and we could say also Cuba would be a good option. So we'll just stack those like that. Well, then in that situation, we can go and provide a hello or hola or however you pronounce that. Then to break out of the checking anything else, we're going to throw break inside of there. And then we can go and throw in another condition. So we'll throw this here, and we will, in this situation, say France this time, which is a match to what we just had there. And we can say bonjour. You could then also check the next statement if you'd like by going go to case, if you would want to continue that on for any reason. And then let's also go case and Japan. And then let's go and print this inside of here. And then if none of those match, you can come in and say default, and then you can go and just put in hello or whatever you want to put inside of there. All right, so there is a rundown of switch. On one thing, let's say this was a number and you wanted to check a range. You could also do that, and I'll just show you here real quick. You could do something like case 7, and then you could go through case 13 if you wanted to check for any of those values from 7 to 13. All right, so there you go, a whole bunch of information on conditionals. Now I want to talk about looping. Now with loops, of course, we're going to have our regular old for loop, which is just going to go and cycle through the values, the changing values of I, and it's going to be based off of a condition. So we're going to say while I is less than 5, we want to continue looping. And then we need to increment the value of I, and basically everything is going to continue looping as long as this condition remains true. And also we have our for each, which is going to make it very easy to cycle through arrays and strings or whatever you'd like to work with. So let's go and create one here. We just be able to come in and say for each, and it's going to take the values of the arrays, temporarily store them inside of X, and then you just put in the array you want to cycle through, and then you can go and print that out too if you'd like. And you can see both of those working over there. We're also going to be able to work with ranges. So we can just go X again, and we could say we want to cycle through 5 to 10. Once again, printing those out each time. You can also work with associative arrays. So let's create a double where all the indexes are strings. And then let's just go and throw some junk values inside of here, A, and then have this be 1, and then the next one be B, and have that have the value of 2. We would then be able to use our for each to cycle through and get keys and values by going key and V, or K and V, and then the associative array we're cycling through. And then we can go K and throw a space inside of there, and V, and you can see that worked as well. You could also go and get both as a group. So X, and how you do that, get the associative array, and then you say by key and value. This isn't the easiest thing. We're going to use formatted here, and we're going to say that we want a string and this, and then go and get our key, and then also go and get our value. And of course, that looks exactly the same except where I went and threw the colon in. It's very important to know that you are actually working with copies of these values. So let's go like this and create 1, 2, and 3, and 4. And for each, so I'm going to go X and get this guy right here. And then X multiplied by 2. So you're going to think that whenever we did this, this is going to multiply each of those values by 2. Well, let's see what happens if we actually go in there and print that out. However, you see that nothing has changed. If you would, inside of this block, want to actually refer to the actual values outside of the block, you just put ref inside of there, and now you get the answers that you would expect. Another looping option that's available to you is the while loop. And with the while loop, your thing that you're going to be checking over and over again with your condition has to be outside of the while loop. And we could do something like while wi is less than 20. We want to continue looping over and over again. Let's throw this in between brackets or parentheses. And let's do a couple other things. Let's say we only want to print even values. Well, we could say if, and then WL, and do the modulus trick again, is equal to 0. In that circumstance, we're going to print out the value because we know that it's an even value. So like that. You don't want to forget to come in and increment this guy so that you don't get stuck in the loop forever. And if you want to jump back to the beginning of this loop and continue looping, you just throw continue inside of there like you do with many other languages. Otherwise, you could come in and go if WL is greater than or equal to 10. Well, in that situation, we want to stop looping altogether and jump completely out of the loop down here. And you do break for that. And then, of course, don't forget to come in here and increment this value. And also, don't forget to close your while loop. And I inadvertently called this WL, that's WI. Let's go and change those. And then we will run it and verify that everything is right with the world again. And there you can see that it worked. Okay, and it only printed the even values. And then the final trick here is the do while, and you use it whenever you want to guarantee that you're going to cycle through the loop at least one time. Let's do a little guessing game thing here. I want to do the guess. I'm going to give this a value of 0, and then I'm also going to come in and do secrets number is equal to, and what should it be? How about 7? And what we're going to do is go do, and then inside of here we'll say write and guess. So the user will guess what our secret value is. Then I'm going to go read F, and I'm going to say that I expect a decimal, and whoops, make sure you put your quotes around it. So I expect a decimal, and then I expect a new line afterwards. And then I want that stored inside of guess. Well, then after that, I'm going to say we want to continue looping forever as long as the secret number is not equal to whatever the user guessed, and then put a semicolon at the end of that. And then after this, we can go and do a simple write line and say that you guessed it, otherwise they would have never left our loop. And this is read F, of course, so let's save it. run it, and if we come in here and guess 5 and 6, it doesn't work, but 7 does. All right, so there's a rundown of loops, and now what I want to talk about is functions. Functions are going to follow the format of the return type, whatever the data type is for what the function returns, or void if it doesn't return anything, the function name, and then parameter types, and then all of the parameter names separated with commas. So let's go and create some of them for you. Let's create a simple thing that just goes and adds values together. So it's going to return an integer, and it's going to receive 2 integers. And then it can just go return, and we can just go x plus y. And there you go. That's a simple function. And we can go sum like this, and then go and call our function, get sum, and throw, well, not that. Let's go 5 and 4 inside of there. Make sure this is lowercase x. And if we run it, you can see the sum comes back. All right. Well, we're going to get much more complicated than that, though. But first, it's very important to understand that just like I demonstrated previously, whenever you change values in loops, that the outside value is not changed. So let's come in and let's create void and change me. So this doesn't return anything. And it gets an integer, which is going to be called f1. And we're going to say that we want to change the value of f1 to 5. Then what we'll do is outside of our function, we will create f1 is equal to 10, and then we'll say change me and pass f1 inside of it, and then we will see what the value of f1 is afterwards. So we can do that. And if we run it, you can see the value is still 10. However, if we would go in once again and go ref like that, meaning that we want to reference the outside value, you can see the value is 5. All right, so that's another way to work with functions. Let's say you would like to receive a variable number of arguments and add them up. We could go get some 2. And how you do this is we're going to say a dot dot dot, and then afterwards a, and I'm going to call this args for arguments. And then we can say int sum is equal to 0. And then for each of those values, which is going to be stored in the args array, we are going to want to go and add those to sum. And then after we have gone through every single one of them, we can say that we want to return the value of sum. And then go and show those values. So sum, and then get sum2. And we can throw in as many values as we'd like, and it will just work, as you see right there. Let's say we would like to return multiple values. How do we do that? Well, in this situation, I am going to return an integer array. So I'm going to say get next 2, and it's going to receive a value, and then it's going to return the next 2 values that come after it. Well, I have to create my array, call it next 2, and it's going to be equal to, and you can go ahead and just perform these calculations directly inside of here. Not a problem, and that creates the array. And then we can go and return the array because we defined that that's what we wanted to do. We can then go and create an array on the outside. Let's call it next 2 as well, and equal to, and go and call our function, which is get next 2, and then pass a value of 1 inside of it. And then we can output this just to show that it indeed did work and we received multiple values. I'm going to show you another way to get multiple values as well. And there it worked. Now here's an example of how we can use recursion, which is just a function calling itself, and we're going to calculate a factorial like I like to do in these tutorials. So let's say we receive a number, and whenever you are calculating factorials or simply having a function that calls itself, you need an out. Here is our out. Whenever the value of num is equal to 1, in that situation we're going to stop calling the function over and over again. So there's that. Then what we just need to do is just go int, and result is going to be equal to num times, and then call the factorial again, except here we are decreasing the value of num, which will eventually get to the point of being 1, and I'm going to show you how all this works here in a second. And then we can say return the result after we're done cycling through all those. We can then come down here, outside of our factorial function and say something like factorial 4 and go and call the factorial function, pass 4 inside of it. And you can see that the final answer comes back as 24. And the way that works is you pass in a value of 4. Here that is. Here you can see we're calling the factorial function again. Now it's 3 because we decreased the value by 1. So that 3 then jumps down to this point, and then we decrease the value again to 2, jumps down here, and here you can see that we got to the point where we called our factorial function with a value of 1. It returns a value of 1. That's this guy right here. We are then able to solve this calculation. This 2 up here jumps over here. We're then able to calculate that calculation. We get a 6. We put the 6 up here, and then we get the final calculation. So that's how we calculate factorials using recursion in D. And let's do some more examples. Now let's say we went and had a function defined. Any arguments that are going to be marked as n cannot have a value that is changed. So if we go and mark it as n, that value can't be changed. Also, if a value is marked as constant, also inside of the function, that value cannot be changed. So for example, if you would try to come in here now and go x is equal to 1, that would throw an error. Let's go into another one. So we'll go random function 2. Now, if you use out, this is actually going to return values to our parameter. So let's say we go out int and then f2. And then inside of here, we say f2 is equal to 100. Now we can come out of our function and we can say f2 like this and give it a value of 5 and then call random function or random function 2 and pass in the value of f2. Now, if we would say that we'd like to get the value of f2, you're going to see that the value indeed was changed inside of that function. And the reason why, and you can see there it is 100, and the reason why is because we put out there and it directly outputs to the argument. You're also going to be able to overload functions. I need to do this outside of main, however. So let's say we wanted to have a function that has exactly the same name, however it performs different operations depending upon data types. So this is going to add integers like that, and then just quite simply x plus y. But then we wanted to do use the same name, so get sum3. And this guy is going to work with doubles instead. So let's also have this be double. And as long as the parameters are different, then it's going to work no matter what data type you throw at it. It's going to automatically pick the correct one. So we'll go x plus y. And then we can jump down inside of our main function and go and prove that that works. So we'll say something like 5.4 plus 4.5 is equal to, and go get sum3. And pass in 5.4 and 4.5. And you see that it called the correct function. All right, so more on functions coming up. I just want to take a break because I actually want to show something else you can do with functions before I get into anonymous functions and all kinds of other cool stuff. But right now, I want to talk about tuples. Tuples are going to be used to store key-valued pairs. And I'm just going to use auto here for this. So how you define them is you say tuple, and then you go and put in whatever your key is, followed by your value. And we can go and output that just to see what that looks like. And of course, you can do way more than that. You can actually store more than 2 values, even though I wouldn't do this normally, but it can be done. So I'm going to show you that it can be done. So here I'll go B, and then I'll also throw in another data type. And you can also use floats or whatever you'd like to use. So there's that. And let's output that as well. You're going to be able to change values by just referencing an index. So I'll just go 0. And let's say that we want to change that to also be equal to A. You're also going to be able to get values by using indexes as well. So I'll just go T2 and go and get the value that I specifically changed. And this is the reason that I'm doing this. You're actually going to be able to pass multiple values into functions using tuples. So let's call this print tuple. And string s and integer I. Make sure you put a comma between all of these. And then I'm going to say right line, and then s, and then throw a space inside of there, and I, And we'll be able to come in now and do call print tuple and T1 and follow that up with expand, and it automatically is going to line up with those two arguments. And likewise, you're also going to be able to return multiple values. How you do that is you say you're going to be returning a tuple, which is going to be an integer and a string. And let's call this return tuple. And we're not going to do anything with that. And then we'll just say return and create a tuple and return it. So 5 and hello or whatever. And throw this down here. And I'll go auto T3 and call return tuple. And then we can go and output the value that was returned. And there you can see all of those worked. All right, so a couple more tricks you can use with tuples as well as functions. And now I want to talk about anonymous functions and sequence processing. Now, an anonymous function is basically what it is. It's a function that does not have a name. So let's go and let's create. I'm going to show you a ton of examples here. Let's go and create an anonymous function. And what it does is you just define what values are going to be passed to it. So it's going to receive an integer. And what it's going to do with that integer is multiply it times 2. Now, technically it has a name in this situation, but I'm going to show you in a moment how it would not. So then I can call this anonymous function like this, and it automatically works. So let's do something even cooler and more anonymous. So what I want to do here is I want to use map to multiply all values inside of an integer array by 2. So I'm going to go and create this array and equal to and 1, 2, 3, and 4. So let's multiply everything times 2. So I'm going to go auto AF2 is equal to, and then I'll go map with exclamation mark. And what it's going to do is it's going to get each individual value out of that array and then multiply it times 2. So there we are. Everything is self-contained. And then at the end of it, you have to put the array that you want the operation to take place on. And if you do that, that is going to be stored in this guy, as you see that it is. And there are tons of little cool tools inside of D for doing things like this. Let's say that you would like to combine arrays and do the same thing. So let's create another one, and we're going to use chain to do that. So I'm going to call this A8 is equal to 5 and 6 and 7, and auto again, and this will be AF3. I'm going to use map again, exclamation mark. Everything's the same, except I'm going to combine the arrays directly inside of here. And how you do that, like I said, is you say chain, and that automatically combines those two arrays. And then we can output it just to prove that I am not a liar. And there we go. And there's many more cool things we can do. Another thing is there is a function called filter, which will, in this situation, I'm going to only get even values. So I'm going to say AF, well, this would be AF4, and I'll go and get that array and filter and exclamation mark once again. And here, once again, I say each one of those values inside of the array. I want to check if the modulus of 2 is equal to 0. And if it is, then it will filter into our final results. And once again, you can see that it went and filtered out only the even values. There's another function called reduce, and what it will allow you to do is perform the same operation on values over and over again inside of an array. So we'll go and call reduce and exclamation mark. And what we're going to say here is we want to get 2 values out of the array instead of just 1. And then we want to add them as we cycle through this. So that's what that's going to do. Then I'm going to say I want to start with the value of 0, and then I want to add all the other values of the array and then get a final result. And we can do that as well. And there's our final result of 10. More stuff. You'll also be able to use reduce with max. You can combine all kinds of different functions together to perform operations. So let's say we wanted to get the maximum value inside of an array. We can say that we want maximum value, and then we just pass in what we specifically are searching for. And then output that information. And there is 14 as our maximum value. There's more and more. Let's do something really cool here. Let's say we would like to generate a random range of random values. All right, so what we're going to do is I'm going to say auto, and I'm going to use the clock to get the current time. If you remember when I did this previously in the tutorial, so UTC. So this is going to get that, which is going to allow us to get seconds, which is going to allow us to use that as a seed. And I'm going to mark all these as 2 so it doesn't mess up any of the previous code. So if I want to get seconds, there that is. And then I can go auto and ran2, and we call random and pass our seed into it. So there's this. And then auto once again, and random values equal to. And here's the cool guy. This is generate. So I'll throw this inside of there like that. And it's going to perform our random number generation to create this array here, or this range. So we'll say 1 through 2000 is the random values that we are looking for. Throw parentheses on there, and then let's, just to keep this manageable, let's say we only want to get 10 results instead, of a million miles of them. And then we can come in and go back to our old friend for each and cycle through all of these random values that were created for us, and then we can output them onto our screen so we can see them. So a neat thing we can do with generate. And there it is. And there's your random values. And if I run this again, they're going to be even more random. All right, so cool stuff. And now I want to briefly talk about enumerated types. So an enumerated type is going to be a custom type that's made up of a bunch of named constants. And it's normally an uppercase letter. So let's say I wanted to go and have a custom type based around playing cards. So there's clubs, there's diamonds, there are hearts, and there are spades. So there we are, created that. And now I can go and create a card and then use suit followed by heart. And then if I output this guy, it just using card, you're going to get the constant and nothing else. Whoops, had an error, and that shouldn't have put that semicolon inside of there. Okay, so let's run it again. And there you can see heart came back. Okay, so it's just a way of creating custom types using constant values. So neat stuff. And now I want to talk about exception handling. All right, so through exception handling, you're going to basically be able to block potential errors. And with the example I'm going to use here, you wouldn't normally handle divide by zero errors this way, but this is just an easy example to understand. So what you're going to do is you're going to surround problematic code using a try block. And here I'm going to say 0 is equal to 0. And then what I'm going to do is, well, another thing you could do is you could actually go assert and 0 not equal to 0, and then throw can't be 0 like this, if you'd like. So you can test that out to see how that works. But basically that's another option to throw the exception. But I'm just going to use a straightforward thing. I'm going to say if 0 is equal to 0, then throw an error that's going to be handled. So how do you throw your error? Is you say throw new exception, and then the message you want attached to that that's going to show on the screen. So that can be can't divide by 0. And then if there is no problem, 0 was not there, well then in that situation we could say good int is equal to 10 divided by 0. Then how you handle or catch and solve these problems is you say catch exception and E, and then you could go and print out a message to the user, E MSG, like that. And then you also have finally, whenever you're using exception handling, and in this situation you would do things like close files and things like that. So I'll say cleaning, and we know we're going to get this error, and it just keeps your program from basically not crashing. Okay, so pretty quick explanation of exception handling. Now I want to talk about file I/O. Now, whenever you decide to work with files, you're going to have different commands you can issue. If you put a W in there, that means you want to open it for writing, and if the file doesn't exist, you want to create it. A handles if you want to append. This is used for reading. This is going to be reading and writing. This is going to be reading and writing. And then we're going to have reading and appending all in the one little guy. So here I'm going to actually go and create a file and show you how that works. So let's create a file, and this you have to call this guy, and you're going to pass in whatever you want the name of your file to be. I'm going to call mine my file text. So it's a text file. And then I'm going to put that command in there that I said. I'm only going to use write in this situation. So it's going to overwrite any data that exists there, create the file, do whatever. So then I'm going to go write line, and I'm going to say some random text. And if you would like to go and write some more stuff inside of there, well, you can do it. And there's going to be a new line in the document, of course, and we'll say more random text. And then after you're done writing to your file, you're going to say you want to close your file. All right, now to verify that I actually did it, I'm going to go and create it again, and I'll say file. I'm going to reference the file that I want to work with, and then I'm going to read from the file. And then I'm going to issue a while loop, and this is going to continue to cycle as long as additional lines are inside of the file. So you go file 2 until end of file. And then we can come in here and output all of those lines here. I'm going to throw chomp inside of here, which is going to get rid of the new lines that are going to potentially be there, or we know are going to be there. And then how you read lines from it is just using read line like that. And then after we're done with that, we can come in and we can close our second file that we created. And if you run it, you can see that not only did I write to the file, I also read from it. Okay, quick explanation of how we can use file IO. Now I want to talk about pointers. Now you're going to be able to work with pointers just like you do inside of C, and a pointer just stores the address of a variable's data in memory, and what we're going to do is create one. So I'm going to go and call this 43. And now if I want to store the address, all I need to do is go int, and there you are. This is a pointer. I'm going to put a P in front of there just so that I can see that. And then I use the reference operator before the variable to get that address, and that guy is this one. And there we go. Now I have that. I can go and get the address if I'd like, just by going address and P value. And then I could also get the value stored at that address just by going value once again, and then put a star in front of it. And that is going to get me the actual value at that address, as you can see right there. And you'd also be able to pass a pointer to a function if you would like. So let's say I wanted to change the value for this variable. How you would set up your parameter is go int with a star and P value. Then inside of it, to change the actual value, star P value is equal to 22. And then this doesn't return anything, hence the void. Then what I can do is say change pointer value, and to pass it in there, I just go and put the reference operator like that. And then outside of here, I can go and show that I was able to directly change the value inside of our function. And if I run it, you can see that it worked. All right, so quick overview of pointers, all the important stuff. Now I want to talk about structs. Now a struct is a custom type that combines a whole bunch of other different types of data, and how you create one is you go struct, and let's say I want to create a customer. I could do things like store the customer's name. I could also store the customer's phone number. I could store like a balance that they owe to us. I can give default values. You're also going to be able to define static variables that are values that are part of the struct and not, and you know, whenever the value changes, it's going to change for every single guy that you create from your struct data type. Now let's go and use it. So let's create a new customer, and you just go customer, and C1, and let's add some information. I'm going to show you a couple different ways to add information. So we'll go CNAME, and let's say this is Paul Smith, and then let's say the telephone number is that, and then we'll say that he has a balance that he owes to us of $340.10. We can then reference this static value here and say number of customers plus plus, but we need to reference it with customer, which is the struct's name. Remember, that's part of the struct. We could then come in here and output this information. So I'm going to do some formatting on this, and I'm going to say call, and it's going to be the customer's name at, and then go and get the customer's telephone number about, and then go and reference the balance that the customer owes to us. And then I can go and get each of those individual values just by using C1 and name, and C1 and phone, and then C1 and balance. And there you can see I did. All right, so let's show you a couple more things here. You could also create a customer all on one line. So I'm going to call this customer 2 is equal to, and then we can say Sue Smith, and Sue Smith's telephone number is very similar to Paul's. And then we can say that Sue owes us $18.90. She's not as much of a bad customer as Paul is. And again, we'll reference our customer, number of customers is what I called it, number like that. And then we can come in here also and just go and output number of customers, just to show you what that looks like. And how you reference it again is using customer and num_cus, like that. All right, and we run it. You're going to see that number of customers comes back as 2. All right, so there you are. Example using structs. Now I want to talk about classes. Now, classes are basically going to model real-world objects or systems by storing their attributes, such as height and weight, and then simulating their capabilities, such as eating and running. So let's say we wanted to create an animal. We wanted to simulate what an animal is. Well, we need to list its attributes. So it's going to have such things as a name, and it's going to have something like height, and it's also going to have a weight, and maybe it'll have a sound that it makes, okay? And then you need to simulate what makes it special. So we could, well, first off, whenever we create a new animal object, let's say that we also want to track the number of animals that are created. Well, like with structs, we can go and have values that are shared by every single animal object that is ever created. So I'm going to call this number of animals. And the major difference between structs and classes is with classes, you're going to be able to limit access to data. That's called encapsulation. And you're going to be able to allow fields and methods to be inherited. And also you're going to be able to allow subclasses to be treated as if they are superclasses while maintaining changes in the subclass. I'm going to show you an example of that if that doesn't make sense. And that's another fancy term called polymorphism. I'm going to show you an example of that. Don't worry about it if it's confusing. All right, so a constructor inside of D, and this is just going to be a function that is called every single time we create a new animal object. You're going to start that off with the word this, and it's going to be able to receive values passed inside of it. So we can say double and height and double and weight, and then also a sound. And just like before, we're going to be able to put all of these on separate lines without causing any problems. So let's do that, and that looks fine. Okay, so now we're going to use the term this once again, and we're using it because we create the class before we create any objects. So we don't know what the name of the object is going to be. So this allows us to go and refer to the actual object without knowing its name. So we can go and put this again for weight is going to be whatever the weight is they passed into us, and then also a sound that they passed into us. So let's just throw those all in there. All right, and then let's say we also want to increment the number of animals that have been created so far. So number of animals and then increment it. And that's the same as that, and that's the same as that. Okay, so this is our constructor called every single time we create a new animal object. This is number of animals. This is marked static. That means the value changes here. It changes for every object. And then these are going to be the attributes that are going to be different for every single animal object that is ever created. So let's do some more things. Let's come in and model a capability. So a capability of an animal might be to make a sound. So we are going to simulate that. So let's go and we will just do something like, let's do this outside of here, this name, and then inside of here we'll say something like says, and then refer to whatever the sound is that we set for our animal, marked as void so it doesn't return anything. Let's go and create another one that's get info, and it's just going to spill out a ton of information about each of our animal object types. So this inside of here, I want to use formatted output, so I'm going to put an F inside of there. And here I'm going to say the name is, and then I want to go and put specific information about height, and then we'll also go and get weight, and like this, and let's set that in pounds. And says, and then whatever the animal sound is. And then to go and get all those and put them in place, you probably guessed it, I just go this, and this is going to be height, and then this is going to be weight, and then this, and follow that up with sound. All right, and that's all that function is going to do. You can also, I said we have static variables like we have up here. We can also have static functions or static methods. And these are normally utility functions that the animal itself wouldn't normally be able to perform. So let's go and say static void, like for example, most animals cannot count very well. So we're going to put this in a static function. So I'm going to say get number of animals, and it is going to go and output onto the screen the number of animals, and then whatever the number of animals is. So number of animals, and that will output it. All right, so I think that's enough stuff for our animal class. Let's go and start to use it here. But before I do, what I want to do is talk about inheritance. So let's say I wanted to create another class that is going to have all the capabilities of animal and all the attributes, and I didn't want to type all this stuff in again. Well, how I do that is I inherit, and how I inherit is putting a colon and followed by whatever the class is. Now you can only ever inherit from one other class, and you're going to see how we can use interfaces here in a minute. But I'm going to automatically get every single thing, every line of code that's here inside of animal is automatically going to go down inside a dog again. And then I can just add the things that I want in addition, such as an owner. So I can then also create a constructor for my animal, and it's going to receive a name. It's also going to receive a height and the weight, and it's going to get a sound, but also it's going to get a owner. So owner. Now let's say it would be very convenient to have all this stuff processed inside of this guy up here, this constructor for animals. Well, actually you can. And how you do that is you just say super, because animal in this situation is known as the super class for dog. So we're just going to pass in all of these different things up into the super animal class and have it process everything for us. So go and pass in name and height, weight, and sound, because we can't pass in owner because owner doesn't exist in our superclass, so we didn't do that. So we need to process that on our own. So owner is going to be whatever the owner name is that they passed inside of here. And there, now we have dog has its own constructor. Now, if you'd like to override or change some things, like for example, get info's up here, and we would like to add in the information about the dog's owner, you can do that just by saying override, and what you specifically want to override, which is going to be get info in our animal class. So we'll do this and throw that there. If you want to call a function that is in the super, even if it's the same one, you can just do it like that. And there it is. And then you can go in and put the things in that are different about your dog class, which is going to be that you want to list out the owner's name. Owner is, and then put in whatever the owner is, and then go and get that information by saying this, which is the dog's name, and then this, who is the owner, is going to print out in addition to what previously was there. Now let's go and create animal objects and dog objects and see how they differ. So let's go and create Jake, an animal, new animal, and Jake, and 35, and 140, and let's say that Jake makes the sound of wolf. Well, we can then come in here and say get info and see how that works. And then what we'll do is create Paul, who is a dog object, and dog, and then pass in all our information that's relevant and how Paul is going to change. He's going to say grr, and also Paul has a owner who is named Robert Hansen. Lucky Paul. And let's go and get Paul, get info, and see how that differs. And we can come over here and test this, see if I made any errors. I did. 71, where's the error at? 71. Oh, I forgot to put new here. So there's new. And run it, and you can see right there, the Jake and the Paul worked, and also, whoops, why didn't that work? Oh, I see why. I forgot to put the F inside of here, so right F line. And now you can see that everything worked out exactly as we liked. But previously, I said that you were going to be able to actually call subclasses as if they are superclasses. So in this situation, we would say animal, and let's give this animal the name of John. However, have it actually be a dog. And the way polymorphism works is as long as a function is defined in the superclass, as long as the subclass, you can refer to dogs as if they were animals, and it will automatically map to the correct function, and automatically, even if the function's overridden like getInfo is here, it's going to automatically execute the correct function. And this is very, very useful in more advanced programming, which I am not going to get into the advantages of polymorphism. I have design pattern tutorials and all kinds of stuff like that if you'd like to learn more about that. Larry Eiler, and let's go and get info just to prove that we're able to call this function without any problems. And then let's also go and show that we're able to use these static variables to track the number of animals that were created, or the static method that we defined. And you can see number of animals is 3. All right, so cool stuff. Let's say I wanted to add some additional functionality, because remember, you can only ever inherit from one class. Well, there's ways around it, and the way around it is called an interface. And basically, you're going to create interfaces whenever you want to be able to add functionality to a class using multiple interfaces, or in the situation in which it just doesn't make sense for an interface to ever be an actual object. So let's say we wanted to define if a object is drivable or not. Well, we just go interface drivable, and then you can define the different methods that absolutely must be defined if they inherit from this interface. And those are going to be a function called move, and then another one called stop. So if you inherit from the interface, you absolutely have to go and create a move and a stop function. And how you would inherit from that is, let's say you have a class vehicle. Well, you just go drivable like that, except you can have a whole bunch of commas, or a whole bunch of commas there, yeah, with more than one interface if you'd like. And then the only requirement is that you actually create these functions inside of here if you inherit from the interface. And I'm not going to put anything inside of there, but you can if you'd like. So there you are, and there you go. So that's how we would create an interface and then inherit it. There's also another thing called an abstract classes. And basically the only difference between an abstract class and an interface is that abstract classes can define functions that must be implemented, just like an interface, but they can also define implementation unlike interfaces. So I'm going to create one here. So we'll say flyable. Let's say we want to define if something can fly or not. So I'm going to go class and flyable. And then inside of it, I can say abstract void, and then void and fly. And then instead of just putting a comma here and not defining anything, I can actually throw something in there if I'd like. So I could say something like I'm flying. And I'm not going to go into all the details about all of those different things. You could also come in and go abstract void and crash and say that that must be implemented, but do not define any functionality. All right, so there you go. That's a rundown of some object-oriented features inside of D. And now I want to talk about templates. Now, templates allow you to define algorithms that are going to be able to work with multiple different data types. So let's go and create one. So let's say we wanted to go and add different values together. We just go get some 4, and we're going to define that our unknown data type, or multiple different data types, are going to be represented by T in this situation. So I can just go T and X and T and Y. And all that we know here, we don't know what these data types are, we just know that they are all going to be the same. So then what we can do is we can come in and maybe go and add these together. So we'll say something like X and X, and this is going to add them, and then throw in whatever the value of Y is, and then we can say equals to, and then X plus Y. And this can work with any numeric data type, X plus Y. All right, so there we are. Now we can jump out of here and we can reference this new version of getSum by passing in either an integer, or we can also go and pass in a double and just know that it is going to work. So 5.6, whatever you'd like. There's that. And whoops, I had an error, and that's because I didn't put getSum 4. There we are. And if we run it, you can see that it works for either one. And there you go. There's templates, and let me show you another example. You're also going to be able to use templates any place you define types, and you can even define template blocks of code. So I'm going to show you how this works. You can say template, and I'm going to call this temp sample, and I'm going to say there is my basically fill in for whatever I'm going to work with. Now I'm going to create a struct inside of here that's going to be called shape, and it's going to have some data type, and it's going to be height, and it's going to have another one which is going to be the width. Then what we can do is come down here. This is going to also return the same data type, and I could say something like get area. It is going to receive a shape, and then it's going to provide an area by returning a value. So I could say shape height multiplied times shape width. So now that I have that all defined, I can jump out of here and I can say auto shape is equal to temp shape and int shape 4 and 5. So I'm working with integers, so we know what T is. And then I can go and calculate my area. And how I do that is I just go temp shape. Again, we're using integers in this situation. And then get area and pass shape inside of it. And that is automatically going to work. Whoops, I typed in temp shape. I meant to type in temp sample. So let's throw this inside of there like that. And throw that inside of there. And let's run it. And you can see that that worked. All right, so there's some different examples of how we can use templates in a whole bunch of different ways. Now I want to talk about mixins. Now, a mixin is going to allow you to actually generate code at runtime. So I'm going to actually create this outside of main, and I'm going to create 2 mixins. One that's going to generate a line of code, and another one's going to actually create a function. So I'm going to go mixin, template, make, type, and not going to define what it is, X. And this is automatically going to go and create a variable of whatever type I tell it to, and go and place it directly in there, and it's going to execute. All right. I'm going to create another one, mixin. Again, I'm going to use template again, getSum, and there is our type. And what this is going to do is create a function called add that's going to return whatever this guy data type that's passed inside of it. And it's going to receive also two attributes and then return a value. So x plus y, and there you are. So this is going to create a line of code. This is going to create an entire function directly at runtime. And how I do that, up inside of main, I am going to go mixin, call make type, say that I want it to be an integer and that I want it to have a value of equal to 10. So what this is going to actually generate at runtime is int var1 is equal to 10. So that is actually going to go exactly wherever that is. So let's get rid of that, otherwise that will cause an error. And let's go and create a function also using the other mixin by calling get sum. And then the type I want to work with here is going to be a double, and that's all I need to do for it. Then what I can do is go right line, and I could do something like 1.2 plus 2.3 is equal to, and call this function that previously doesn't exist, called add, pass in 1.2 and 2.3, have them both generated real time, and execute. And there you can see they did. All right, so brief example of mixins. And now to finish up the tutorial, I want to talk about threads. All right, so a thread is just a block of code that's expected to execute while other blocks of code execute. And what I'm going to do here first is I'm actually going to have a bunch of blocks of code execute one after another, and then I'm going to have them execute in parallel. So let's go and just pause our way through this. So I'm going to go do stuff and integer x, and what this is going to do is just simply state that a thread has started. So I'm going to go x and starts, just so you can see that it does start. All of these threads are going to execute together. We can then call, or they're going to execute, and then the next one's going to execute, then the next one's going to execute. And they're going to sleep for 1 second, and then the next one's going to execute. So I can go and grab this, and then we can say stops. So I'm going to give you an example using parallel execution, and then another one where it is going to execute not parallel. All right, so I'm also going to go and get our time, just so you can see the amount of time that execution occurred under, and then auto get our seconds. And then I'm going to say do stuff, pass in 1, and then call do stuff a couple more times, and then go and do this again to get the different amount of time here. Let's have this be now 2, ss2, change this to now 2, and then output the seconds, which is going to be ss2 minus ss3, correct? Or not? Oh no, minus ss. So this is going to be very straightforward. And there you can see it starts, it stops, the next one starts, and then it stops. All right, and it took 3 seconds because there's 3 of them. All right, now I'm going to do one a little bit more complicated because I'm going to execute a whole bunch of them in parallel. So I'm going to create a class here called worker. Each worker is going to have an identification number. Also going to have a constructor, which is going to assign the ID, and then it's going to perform some work. So what we'll do, I'll just call this work, just to keep it simple. And what this is going to do is go and get our identification number that we assigned to our worker. And then we can also get the thread ID. Each of the different threads that is executing, a thread's just a block of code, is going to be assigned an identification number. And I just want to show what that is. Also, I'm going to show that a thread has started. So let's just go thread and then ID and starts, just so you can see that they're not working at the same time. And we'll use sleep again, just like we did before. Sleep. And then here, we'll do the same thing again. I'll just do this part. Stops. You can also get the total number of cores for your specific computer. Let's just go and grab this, which is going to be the total number of blocks of code you're going to be able to execute at a time. So we can go cores and then follow that up with total CPUs. Just some interesting information. And then let's go and create a whole bunch of workers in an array. So workers is equal to, if you want to go and create objects, worker objects inside of here, you just go like this. You don't have to give them names. And then I'm going to give each of them a different ID number so we can track them. All right. And now what I'm going to do is I'm going to have them execute in parallel. So we like this, and how we do that. Parallel workers refer to that object array of workers. And then we will call the work function for each of them. So work, like that. And whenever you do this, you're going to get different results. Let's go and get rid of this. All right. And when we execute, you're going to see they start. So 1 started, then thread 0 started, then thread 2 started, and then they went and stopped in different patterns. And if we run this again, you're going to see that it also is going to do, well, that time it did exactly the same thing. Let's run it again. And there you can see it went in a different pattern again. All right, so they're all trying to execute their block of code. However, they're hitting the sleep here, which pauses them for a split second, and then it continues onwards. So very brief explanation of threads, but I think you get the idea of how threads work and have a good jumping off point for learning more about the programming language D. And like always, please leave your questions and comments below. Otherwise, till next time.